This is called an inverting amplifier. Now, I know you've seen the symbol before when we talked about all this stuff here, but this is an op-amp circuit that doesn't switch the output. The output doesn't switch high and low. The output can gradually move, and it can achieve any sort of voltage in its power supply range. Just let me give you a few little hints here. Some of the things that you need to know are that this little connection here, which connects an output to an input, which seems really bizarre, connecting an output to an input, but this is a traditional way of building a circuit, and this is called a feedback connection. A bit of the output is fed back to the input, and it's called feedback. Now, when you feed it back to the negative input, it's called negative feedback. It's a bit complicated to explain why it's used, but it's used to stabilise the circuit. And with this negative feedback connection, the circuit works in a very simple and very predictable way. And whether you can follow the theory that leads to it or not doesn't matter. Whether you understand the theory behind it is not quite so important. It's just knowing how to use it. This output will be bigger than the input. It's an amplifier. If you, I've had a feeling I talked to you about this, but I probably haven't. I must be in a different group. Let me just give you an example. You know, I sort of use music and cars and things as sort of an example of something. If you take a signal here, a voltage is sometimes called a signal. Right? If you take a signal voltage from, say, a CD player playing music, or maybe a signal from you know, a record deck, you know, that's playing a record, right? It's going to be a small voltage signal. Or maybe a microphone. Plug a microphone into this, and that becomes your input voltage. What does it do? It amplifies it. So it makes the signal bigger here. Now this circuit, you can plug a microphone into here. Yeah, take a microphone, 2 wires on it. One wire goes to that.
Microphone, so, yeah?
Sorry?
A normal microphone.
Normal microphone, yeah. Take a normal microphone, it's got 2 wires on it. One wire connects there, the other wire connects to the ground. Connect an earphone here, or some headphones, 2 wires, one for left, one for right, if you both at once. 2 wires there connect to the headphones. It will amplify it. You can hear yourself talking into a microphone. If you wanted to plug in your MP3 player output here and put your earphones there, then the output would be much bigger than it was originally because it's an amplifier. It makes the signal bigger. So the amplifier increases the voltage of what's coming in. Very simply, this little inverting amplifier makes that bigger than that by a ratio R2 divided by R1, and that's all it is. The amplification is normally called the size of the output divided by the input. Yeah? And it has a special term called AV. It's called voltage gain. So if that is 10 times bigger than that, it's got a gain of 10. If that was 25 times bigger than that, it's got a gain of 25. You get the idea. If that's 1,000 times bigger than that, then it's got a gain of 1,000. So high gain is obviously a good thing to get. Low gain, perhaps not so useful. So how do we set this up so that it's got a very specific gain? All we need to do is choose a value for R2, choose a value for R1, and that's what specifies the amount it amplifies. So where does the inverting bit come from? Well, if I put a minus sign there, that's what the equation actually says. It says the voltage gain of that circuit is minus R2 over R1. Let's just take it, not much time left, so I'll just do it quickly. Give me a value of R2. Just give me a value. 3. Okay, so R2 equals 3. Let's say 3,000. We normally use thousands of ohms in this circuit, so let's say it's 3,000. No, let's make it 3K. Okay. Give me a value of R1 that's smaller than 3K. 2K. Okay, so R2, sorry, that's R2. R1 equals 2K. What is the gain of the circuit? Then the gain is V out over V in equals minus 3,000 over 2,000. Right? Which you can see is 3 over 2 is minus 1.5. So what does this mean? Is that if I put a voltage in here, this voltage will be 1.5 times bigger. Yeah? Amplified by 1.5. Just quickly let me explain what the minus sign means. This input signal can be steady DC or it can be a sine wave. It works perfectly well with DC or AC. AC is anything with a sine wave. If I put, imagine I put plus 1 volt there, constant. The output is going to be 1.5 times bigger. So I'm going to get 1 volt multiplied by the gain, which is 1.5. Yeah? Sorry, that shouldn't be volt, it should be 1.5. So what size is the output going to be? 1 volt in, multiplied by 1.5. 1.5, yeah, it's not a trick. There's a minus sign of it, which means that it inverts. In other words, it changes the polarity. So if I put plus 1 volt there, I get minus 1.5 volt out. So if I did that, the inputs, plus 1, V, that's V. The outputs, that's 0. The output will be minus 1.5, V out. Yeah. Now, why you'd use it with DC signals is not clear, but if you put a sine wave in, then it works a little bit better. Because if you put a sine wave in, right, V in, let's say it's got an amplitude of 1 volt, the output will have an amplitude of 1.5 volts. But because it's inverted, means all the positive voltages become negative voltages, and all the negative voltages become positive. So the output, when that goes to plus 1, that goes to minus 1.5. So what we get, is that. 0 times 1.5 is 0. Yeah? And it goes up to plus 1.5 here. So let's see. So you get that something. That's the out. Now that's where you amplify the signal. Yeah? And of course, if you're listening to that on your headphones, you think, well, it's hardly any louder than the original signal. So you choose to put more gain in. Which resistance do I increase to make the gain bigger? One.
R2, yeah.
Yeah. Make R2 bigger, then the gain becomes bigger, doesn't it? So, what would be the gain if I made, if that's 1, well, what we've got here is R1 is 2K.
Make it 1,000.
Yeah, well, I can make it almost as big as I like. Yeah, if R1 is 2K, 2,000, if I made that 20,000, yeah, what happens to the gain? 20,000 divided by 2,000. 20,000 divided by 2,000. 10, yeah. So the gain would be 10. So it's all right. No, I understand. Yeah. So the gain becomes 10. If I made that, if that's 2K, if I made that 200,000K, then 2K, 200K means I get a gain of 200. Yeah. What do you think happens if I just make it variable? No, there's a little symbol that says I can vary that. So I've got a little control now on my circuit, volume control. The signal goes in from a microphone. I can adjust that. I can maybe take it up to 1,000,000. Or maybe I can take it all the way down to 0. In which case, R2 over R1, when that's 1,000,000, that's 1,000,000 over 2,000, so the gain is big. Take it down to 0, it's got 0 over 2K, which is 0. So I've got volume control on here. The fact that it inverts the signal doesn't actually make a great deal of difference with an AC signal. It's useful to know how to draw it, because it does actually do that. But you don't necessarily, you can't tell if that's a music signal, you can't tell that that's an inverted music signal. But if you drive this circuit with a sine wave generator in the lab, you'll actually see the output as an inverted version. Yeah? So it's got a gain, it inverts, you can set up the gain with these two resistances. One final thing, because it's 5 to 4 now, one final thing is that to make this circuit work, just like to make your radio work, you've got to put a power supply on it. Your radio won't work unless it's got a battery in it, will it? So you put a power supply on this chip. This is quite a complex little amplifier chip. And the power supply that we usually use is not a simple 0 9 volts. So it's usually a negative voltage and a positive voltage. And you can create that quite. This is 0. You know, this line is 0. We can supply. This is known as a bipolar power supply. So this is 0. That is 15 volts above 0. That's 15 volts below 0. And that means that my output here can be anything all the way up to 15 volts and all the way down to minus 15 volts. Because the power supply allows that. What you can't do is you can't drive the output of the op-amp beyond the power supply voltage. So you can't keep on increasing the gain of this without a problem, because the output voltage will never go above the power supply. It won't go below the negative power supply. So you do have a limit on this. If you made the gain, you know, 1 million, then you know there might be a point where the output is rising so far it hits the 15 volt line and it won't go any higher than that. So that's a limitation. And these are called saturation levels, these high and low values. And they're dependent only on the power supply voltage. Okay, I think that's a lead. Okay. Yeah, go on. What's known as reference points? Let me show you something. If you make that, if you make that +9